Hello viewers, I'm Kausalya. Today we are going to discuss about Tellegan's theorem. So Tellegan's theorem is nothing but power delivered is equal to power absorbed. Okay, this is the single line which dictates what is Tellegan's theorem is. So here, let's solve the problem, then you will get a clear idea. So here, verify Tellegan's theorem for the network shown below, and these are all the given datas, right? R1, R2, R3 values are given and respective I1, I2, I3 is given and Vs, that is the source voltage, is also given, right? So as I said, power delivered is equal to power absorbed. So here in this case, the power will be delivered by our source and power will be absorbed by our resistors. So here in this case, the value of that is V1, V2 and V3 are calculated. V1 it is nothing but I1 into R1, V2 is I2 into R2 and V3 is I3 into R3. Right. So just calculate the values here. Now the next thing is according to Tellegan's theorem, right? So you can just consider the same formula as I said. Power delivered is equal to power absorbed. So you see these are all the powers which are getting absorbed, right? So how to calculate the value of power that is delivered? It is given by our voltage source here, right? So in this case, what is the value of Is? Can you tell from this diagram? Is is nothing but our I1, right? This I1 at this junction gets divided into 2, right? Therefore, the value of Is is, it is nothing but our 5 amps, right? Therefore, the power delivered by the source is 75 into 5. While writing in the expression, you see that is summation of, here we are having totally 4 elements, right? In the circuit we are having 4 parts, 4 elements. Therefore here the value of K starts from 1 and it extends up to 4, right? And that is summation of powers in a circuit is equal to 0. Okay, either we can give a statement like this or we can give power delivered is equal to power absorbed. So here in this case, the power supplied by the source and power supplied by this resistor plus this resistor and this resistor you have to add. So once you sum up, you see here power delivered by the source is of positive symbol and the power absorbed has a negative sign. So finally the entire value is equal to 0, right? Therefore here the Tellegan's theorem is verified. This problem gets over here. We will proceed with our next one. Our next problem is verify Tellegan's theorem for the circuit shown in figure. Here the value of resistors are given. R1 is equal to 1 ohm and R2, R3, R4 is equal to 2 ohms here. So this is your given circuit, right? So in this case, the first step is, here the values of current is not given. Right, only the value of resistors are given. So we have to calculate the total resistance and we have to calculate the net current, right? So since resistors are connected in parallel, what is the formula here? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So once you solve, here the final value of Rp, it is given as 0.667 ohms, right? Now these 3 resistors are combined into a single resistor and that resistor comes in series with this R1. So here what is the value of R1? It is 1 ohms. Therefore the total resistance is given by 1 plus 0.667, that is 1.667 ohms. Right. Now this is the total resistance of the circuit. Now we can calculate the total current. It is given by V by R, that is total resistance. So we know the values, just substitute and here the answer is 60 amps, right? So this is the total current in the circuit. So as we know the total current, we can easily calculate the voltage drop across all the resistors, right? So here you see the value of Is is, it is 60 amps, right? And this 60 amps gets divided between these 3 resistors, right? So here you see the voltage across this resistor R1 is nothing but, V is nothing but I into R. The value of current is 60 and the value of R is 1. Therefore 60 into 1, that gives 60 volt, right? And here when you look at the circuit diagram, you see all the three resistors have the same value, that is 2 ohms, 2 ohms and 2 ohms. So whenever the resistor values are same, then what happens? The current gets equally divided between them. Right. So here the total current is 60 amps and this 60 amps gets divides between these three resistors. So here the value, that is the 60 amps, is divided equally between these three resistors. So 60 by 3 is nothing but 20 amps, right? Therefore I2 is 20 amps, I3 is 20 amps and similarly I4 is 20 amps. Right. So whenever you have resistors of equal value, no need to go for that current division formula and all. Right. Just think logically and just split the current equally. That's it. Now the next thing is, now we are going to calculate again the voltage drop across all these three resistors, and again the voltage drop will be the same, right? Because the value of resistor is same, the value of currents are same, therefore the voltage drops across the resistors will be also the same. Therefore you see here the values are V1, V2, V3, V4, right? V1 is I1 R1, it is 60 and all the remaining 3 are 40, right? So now we have calculated the values of V1. We know the values of I1 also. So initially we start up with power delivered by the source. So here power delivered by the source is Vs into Is. Therefore 100 into 60, which is nothing but 6000 watts. Right. Similarly, therefore the power dissipated by the resistors, they are given by this formula. V1 I1, V2 I2, V3 I3 and V4 I4. So here just substitute the values. If we know the value of V1 as well as I1, similarly V2 I2, V3 I3 and etc. Everything. So just substitute the values here, and finally you see again here we are ending up with the same answer, that is 6000 watts. Power delivered by the source is 6000 watts, and similarly the power dissipated by the resistors are 6000 watts. Therefore here finally the Tellegan's theorem got verified, right? So according to me the Tellegan's theorem is very simple thing. The one and only thing you have to keep in mind is power delivered is always equal to power dissipated. And another thing is you must know the basic circuit logics. That's it, right? You see here a circuit is given, right? So from the circuit it is clear, right? These three resistors are parallelly connected. So the basic thing to convert parallel connection of resistors into a single resistor and the current division formula. Okay, these are all the things. And again, when the value of resistors are same, then the current gets equally divided among them. Okay, whatever may be the value, it gets equally divided. Here in this problem, we are having only 3 resistors. In case if you have 5 resistors, then again all the 5 resistors, through all the 5 resistors, the current flowing through them will be the same, provided the resistors are all of the same value. Right. So only if you know the basic things clearly, then it is very easy to solve problem using Tellegan's theorem. Right. Here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.